The derivative of e to the x squared shouldn't just be e to the x squared. Can you tell me in the comments below how to fix this? Let's talk about why this mistake happens and what you can do to get the correct answer. Remember how the derivative of e to the x itself is e to the x? Well, that's understandable then to think, okay, well, what about e to the x squared? Wouldn't the derivative be the function itself? Well, not quite, because when you have something a little bit more complex such as this, you have to look at the problem differently. I look at it as the layers of an onion. So if you think about making this awesome salad, you've got lettuce, zucchini, Kalamata olives, and then you've got this onion and you start peeling away at it with your fingers. Notice how you start on this outer layer and you're working your way in. And I want you to use that analogy when you approach problems like this because it's really helpful to visualize it. Given a problem such as e to the x squared, think of it as an onion where you're starting on the outer layer being the function itself, e to the x squared. And as you're peeling away at the layers getting into it, getting closer and closer to the function's variable x itself, this inner layer in the example problem you see here would be the power you're raising e to, which would be x squared. When you take the derivative then, what you want to do is almost think of the power of e here almost like a u substitution. So think of e to the x squared as being e to the u, right? And when you start with the derivative of that outer layer, okay, well, the derivative of e to the u would just be e to the u, right? And then you don't want to forget about that substitution you made. So then for that inner layer, you put back in the x squared term and you take the derivative of that. So that would give you the derivative of the outer layer, which would be e to the u, or e to the x squared when you finally put the variable x back in, times the derivative of the inner layer, which is the power you raised e to, being x squared. And we know the derivative of x squared itself is 2x. So then e to the x squared times 2x would be your final answer here. Okay, you know what's really cool about this? For e to the x itself, you can apply the chain rule here, believe it or not. If I go back up to e to the x here, treat the outer layer as simply being the function e to the x, and the inner layer being the power you raise it to, which is just x. So then when you apply the chain rule, notice how the derivative of the inner layer that you multiply the e to the x by would just be 1, right? Because the derivative of x is simply 1. It still works, and it's actually a really cool visual technique I use too. Before I go into the second common mistake that we tend to see, if you haven't already, hit that subscribe button and leave a comment. Tell me what future videos you'd like to see. For the second common mistake we see, I want you to look at this problem x squared sine of x. I tried taking the derivative here, and I got an answer of 2x sine of x. Do you see what I did wrong? Let me know in the comments below. So for the product rule, it's kind of like the chain rule where you've got this complexity in the original homework problem. But the only difference here is that instead of thinking of one function that's a layer inside another, think of it as just sides. When I look at the left side here, I see x squared in the original function. And when I look at the right side, what I notice is sine of x. The next thing I'll do is apply simply labeling each side as its own separate function. F of x here would be what I call x squared, and g of x would be sine of x. To apply the product rule and to get the proper derivative of the original question, x squared sine of x, what you got to do is it's f prime of x, g of x, plus g prime of x, f of x. So in other words, you're taking a sum of two products, and for each product, one part of it is an original function, either f or g, and the other part is the derivative of the other function. So for the left product, f prime of x, g of x, you would have the derivative of x squared, which is 2x, times the original g of x function, giving you sine of x. And then you're doing a similar thing on the right product, but now you're taking the derivative of the other function, which is sine of x, and multiplying it by the original f function versus g, giving you this final answer of 2x sine of x plus x squared cosine of x. So it's pretty simple, and I hope this video was helpful to you. If you haven't already, check out this Calculus 1 playlist for more derivatives, and I'll catch you later.